Hi, I'm Travis LeMoine with Seiler Geodrones and Seiler Design Solutions. And today we're going to take a first look at the DJI Zenmuse L3. So it's a late October day and we were going to take this thing outside and run through everything there, but it's gotten a little bit windy. We're still okay to fly, but there's a lot of wind noise, so it's a little bit more challenging there. So a lot of things have improved with the Zenmuse L3. They've gone to a 1535 nanometer laser with 2 million points per second, a range of 950 meters, 16 returns, and we have two 100 megapixel cameras at oblique angles with mechanical shutters. It also supports pixel binning, so if you're in a situation where you're getting low light conditions, you can switch over to the pixel binning mode and your imagery will be better in those low light conditions. We've also got a substantially improved IMU in this system where we have 0.02 degrees heading accuracy and 0.01 pitch and roll. Let's pop out the L2 here and we'll see how the two of them look in comparison. All right, so you can see the L2 is substantially smaller in every aspect than the L3. So that's quite a bit of difference there. It's also quite a bit lighter. So what we're going to do next now is we're going to take this thing outside. We're going to fly at 164 feet, which is where the range we want to fly our 2 million points per second mode in. We're going to capture at 100 megapixels on the camera and their full resolution. And then we're going to compare that data to the L2. So we're going to fly the L2 at the same altitude, at the same speed, so we can kind of match things there. Our next flight is going to be sending it up to 400 feet, where we will have to turn down the rate to about 350,000 points per second. We'll see how much ground we can capture there. And lastly, we're going to try something, the manufacturer hasn't intended for this, but we're going to try something like a full dome scan. So we're going to send the drone up 400 feet and we're going to sweep around a bit with that LiDAR and see what kind of data we can get. So the thought of that is, as long as someone's going out to a site and you want to get the area around, that might be a pretty easy, efficient way of capturing that sort of stuff from a single location. So let's see how this all works out. What we'll do here is we're going to send this drone up, and first I'll show you the mission setup for it. So I just have an ortho collection. There's my advanced settings. You can see there's a couple interesting things here. We only have single, dual, quad when we're at 200 million points per second. But if we slow that down, then we can do single, dual, quad. I believe that's 8 and then 16 returns. So you have to slow that rate down in order to get higher number of returns. Now the scanning mode, we have linear, we have the star mode, and then non-repetitive. And we also have 2 different photo resolutions. So we'll use the high one for this mission. So we say okay to that. You can see my settings now. Our ortho GSD is going to be 0.5 centimeters per pixel. We're going to fly at 162.5 feet. We've got our altitude. Our speed is going to be 13.5 miles per hour, and that's to support that high resolution camera mode. We've got a side overlap of 40%. So I'm just going to go ahead and save that here. And the 40% too, I should say, like I could go quite a bit lower than that and still get great data. Just in my first couple of missions, I want to make sure I'm flying with higher overlap. So I got my RTK stuff set up and waiting for the battery to finish heating, and then we're good to go. So we've got the data captured now. Let's go ahead and take a look at it in DJI Terra first before we take it into LP360 and see what results we got. So in Terra, I really didn't do a whole lot with the data. I brought it in, I selected point cloud optimize accuracy, a point cloud export, and I had it send out 100% of the points. Didn't turn on smoothing or any of the other data outputs. I really just want to get this right from Terra into LP360 for analysis. Let's go ahead and switch over to LP360 now. we've got 3 different data sets. So one thing you'll notice is we have this kind of gap here in our data, and that's just a daycare facility, and we don't fly over that when they've got kids out in the playground playing. So that's all that is, nothing wrong with the LiDAR systems here. So there's our L3 data, there's our L2 data, and there's our L1 data. So we have very similar capture settings between the L3 and the L2. Except the L3 has 2 million points per second. So we turned that on. We were only flying at 164 feet up. We wanted to get an idea of what that real high density data looks like. We also had the camera running at full, 2 100 megapixel cameras at full resolution. The L2 we had at the highest point mode, I think that's 240,000 points per second. Same speed, same elevation, all those different things are together here between the two. So let's take a look at the differences between the data. And I'm going to zoom into this area where we have captured data from all 3 first. So one of the things that you can see in kind of the progression of the system will become pretty apparent in just a second here. So what I'm going to do is I'm going to create a cross section or a profile view. And we'll just grab the curb area on the east section of our office property. We're going to set a depth of about 1 foot. So what I'm doing here is I'm going from curb to curb, and the depth, the thickness of the data is going to be about 1 foot in our view here. That helps kind of cut down on noise and so on. So let's just take a look. Here's our L1 data. If you see, let me show you what LP360 does here. So as I move my cursor across here, so we're a little bit backwards here, but that's okay. We can see our curb here. So the L1's a bit of a noisier sensor. Let's go ahead and zoom in a little bit more here and go towards the curb. So you can kind of see where that's at. Let's hop over to the L2. We should see some improvement here. Lower noise on that sensor. The curb is somewhat defined, just as it is with the L1. Go ahead and go over the other one, and I'm also kind of scrolling through here too, moving through this cross section. Let's go ahead and flip on that L3. So here we can see a much more substantially defined curve. You can actually see the area behind it where the vegetation starts. Move over to the other side here, and again, there we see a high definition of it there. You'd be able to really well define where our flow line is, our top of curb, back of curb, that sort of stuff is pretty easily seen in this data set. Also keep in mind this is fall time, so we've got probably some leaves, leaf litter and that sort of stuff showing up in our curb there. So the types of feature extraction that we're going to be able to do with the L3 are substantially greater than what we could with the L2 or the L1. Let's go ahead and we're going to switch to a different area. So this is where we have no longer have L1 data. We just have L3 and L2 data here. This is where one of my control points is at. So I'm going to make the same cross section with a 1 foot depth to it, and we're going to look at it with RGB first. So this is L3. One of the nice things about this L3 is that with that high density, I can really clearly see where my control point is. So this control point it's basically 2 chevrons coming together at the points, and this is retroreflective road marking tape. So it shows up pretty well in LiDAR data sets. Let me switch that over to intensity, because there's always a risk that our RGB, our cameras, may not be completely aligned with our LiDAR system. So there we go. We can see a real bright area there with the retroreflective road marking tape. Let's switch that over to the L2. So I might not have as great of a shot at determining where that control point is. Here it is. I'm going to turn that on. We'll go look at the L3, and now the L2 again. I'm going to move our cross section right on top of that, and then we'll be able to see how it fits. So full disclosure here, we did do some systematic error removal. So we shifted the entire point cloud of both the L2 and L3 up. I think what we're seeing here is the Terra, or somewhere something's not understanding our base station, the difference between the antenna reference point and the bottom of antenna mount. So we had to move, I think, about 1/4 of a foot for both of them here. So here's our L2 data looking at the control point. Here's our L3. You can see they fit pretty closely there, but again, I did move the point cloud. So nice low noise data set with the L3. I zoom in here and we might be able to better understand that with our grid lines here. So we see we've got this between high and low, at least over our control point, about 300ths. Switch that over to the L2. It's a little bit noisy to kind of tell where that's at. It's not there. There we go. So we're starting to see the picture there. So yeah, we've got a couple tenths there, maybe 1500ths of a foot or so between high and low. It's a little bit higher than that. So really that L3, it's got much lower noise. We're going to get a lot more point cloud density, and it's just going to provide a better result here compared to the L2. So let's head back to our data sets here. I've got one more. We're going to look at this in Trimble Business Center, another program we're really fond of at Seiler here. So in TBC, this is the entire business park block I flew. So I did do classification and all that. TBC does a fantastic job with that. Other than maybe showing you the colorization of that, I'm not going to jump too deep into it here. We'll just colorize by our region there. There you can see we've got power lines, we have power poles, different barriers, that sort of thing, high vegetation, low vegetation, or medium vegetation, buildings, and ground. Again, it does a really fantastic job, especially with the ground. We can make surfaces based off of that are just fantastic. So one of the neat things I like about this is the range of the L3. So I just wanted to highlight what we see with that. Let me switch back to an RGB. So I did this kind of silly thing that the manufacturer doesn't recommend. And it was kind of to be a bit of an analog to what you would do with a full dome scan with a terrestrial-based scanner. So the application for this would be, you're out on a site, you get done with a project, and then you want to get a rough idea of where all the other buildings are, building footprints in the area. So worked pretty well for that. I wouldn't put a huge expectation on that you're going to get great results, but let me just show you what we did end up getting with that. So here's the kind of full dome scan, and this is all done manually. So after the mission, I went to 400 feet, and I just kind of sweeped around with the LiDAR. And I can see some returns all the way out here. We've got 3,000 foot returns, so their claims of a 950 meter range could be backed up by that. I didn't see anything quite out to 950 meters, but just at this particular site, I wouldn't really expect that. There's some kind of high or low reflectivity stuff out there, and I wasn't really trying that hard and leaving it out there to point it out there to see what we could get. So I could definitely do extraction of building footprints with this. There'd be no issue with that. Kind of see what the road network looks like, parking lots, that sort of thing. Of course, the further out you go, the less information you get, and you start to get kind of facade information rather than, the tops of buildings or the roads or that sort of stuff. This was kind of neat. This is about 1,000 feet out. There's a cell phone tower, and it scanned that pretty well, I would say. So that's it. We're going to put together some other videos and go through vegetation and probably the accuracy results a little bit more deeply, but this was just our great first look at the L3. We're pretty excited about this and looking to see where this takes us.